Here is an explanation for the answer to final exam question number 38 in Alternative Energy Demystified, 2nd edition. If you have the printed book, you'll find it on page 317. We're talking again, as we did a couple questions ago, about a nuclear fission reactor. That's one that splits uranium atoms in order to get energy in a controlled manner. In order for a reactor like this to work properly, it must be maintained in a condition such that what? Well, the correct answer to that question is B. On the average, one emitted neutron strikes another U-235 nucleus and splits it. Well, U-235 being uranium-235, 235 meaning it's the atomic weight of that particular isotope of uranium. If the answer were A, the reaction died down before much fuel were spent, well, that's the subcritical state, and that's what we were talking about in question number 36. That would cause the reaction to die down rather quickly, and you wouldn't get energy for very long. C, neutrons never strike any nuclei. Well, that would mean no reaction taking place at all. Choice D is relevant to nuclear fusion, not nuclear fission. And choice E, that you definitely do not want that situation in a nuclear reactor, because if more than one emitted neutron strikes another U-235 nucleus for every occurrence of the fission, you're going to get a nuclear meltdown situation, and that's no good. That's not what you want in a reactor. We've all read about what happens in nuclear reactors when they melt down. It's just not a good thing at all. So once again, the correct choice to this question is B, and again, we can take a look at a schematic or block diagram of a electric generating plant with a fission reactor. The fission reactor being this thing right here. The heat from this reactor heats up the water in a boiler, and you get basically the same situation in all the rest of these components as you would have in a coal-fired or methane-fired or oil-fired power plant that uses steam turbines. But the heat comes from the fission reactor, which we want to maintain in the critical state, that is to say, one neutron striking an atom for every atom that gets split, so that the reaction sustains itself in a steady state, doesn't get out of hand, and doesn't die down either. Once again, the correct answer to this question is B. On the average, one neutron strikes every U-235 atom and splits it.